Hey everyone, welcome to Algebra 1-2. This section is called Vertex form. We've talked about how to graph a parabola that's in standard form, but now the equation is going to be written a little bit differently, and we're going to learn how to graph the parabola based off of that. So by the end of this lesson, you should be able to identify the vertex and axis of symmetry of a parabola written in vertex form. You should be able to graph a parabola written in vertex form. And you should be able to compare the graph of the parabola to the parent graph, y equals x squared. So what is vertex form? Before we get to that, let's do some review. We've talked about standard form, which is y equals ax squared plus bx plus c. And we know that the a value affects whether the graph is narrower. The bigger the a value, the more narrow it is. The closer to zero, the wider the parabola gets. The a value also determines whether it's going to be upside down or right side up. The b value has a major role in shifting the parabola left to right. And remember, we use that formula x equals negative b over 2a. Now, it's not a direct relationship where if it's like 3x, it moves 3 spaces to the right, negative 2x, it moves negative 2 spaces. It doesn't work quite like that. But the b value does help shift it left and right. If there's no b value, it won't shift left or right. And then the c value takes that parabola and moves it up and down. And that is a direct relationship. If it says the c value is plus 5, then the parabola shifts up 5. If the c value is negative 2, it shifts down 2. Okay, so that's a little bit of review for you. But let's talk about vertex form. Vertex form looks differently. It looks like this: y equals a parentheses x minus h squared plus k. Now the a value in this formula is exactly the same as the a value in standard form. It's going to determine whether the parabola is upside down or right side up, how wide or how narrow it is. So that a value we're already familiar with. But what we're not familiar with is that h that's inside the parentheses with the x and that k that's on the outside of the parentheses. So, we already talked about that. It's the exact same thing. All right. But the h and the k, all right, that's what is different about this. And so that h and the k is actually going to be the vertex. So you should be able to look at the equation and be able to just tell right away what the vertex is. So an important point to note here, notice how it's x minus h. So I've got a negative h in the formula, but a positive h in the vertex. So the sign on that x coordinate is going to change. On this one, we have a positive k, and in the vertex, we have a positive k. So the sign does not change on the k. It only changes on the h. So what we're going to do right now is we're going to take a look at some examples and how we can just look at the equation and immediately know what the vertex is. So here's a worksheet I found online. You might want to write some of these examples down or just refer back to this video. But this section right here that we're going to tackle first, it says identify the vertex of the quadratic function in vertex form. So we're going to be able to look at these equations and immediately tell what the vertex is. So the first one, y equals, let me scroll down a little bit. There we go. Y equals 3 parentheses x minus 7 squared minus 1. Now that 3 out in front, that's our a value. That that doesn't change where our vertex is at all. So when we're just finding the vertex, the number that's out in front of the parentheses, we don't even worry about that. So I see inside the parentheses it says x minus 7. So if you recall, that means I have to change the sign on what's inside the parentheses so that minus 7 becomes a positive 7. And then what's on the outside of the parentheses, that's our y coordinate, and that value does not change. So since it's minus 1 on the outside, it's minus 1 in the vertex. So positive 7, negative 1 is our vertex. So just change the sign on the number inside the parentheses and don't change the sign on the number outside the parentheses. So let's see how quickly this can go. Number 6, there's a +2 inside the parentheses. So that means it's a -2 for your x coordinate and a -5 as your y coordinate. Problem done. Number 7, I see a -3 inside the parentheses, so it's going to be a +3 in our vertex. And since there's no number on the outside, that means our y coordinate is 0. On number 8, I see a -2 inside the parentheses, so I put a +2. And then a +4 on the outside, so I put a +4 in the vertex. So just like that, we're able to identify each vertex. So let's go through this. Let's get the other ones very quickly. This one's going to be a -1, -3. This one's going to be a -4. And there's nothing on the outside, so 0. There's a 1/2 out in front on this one. That doesn't change a thing. I'm just looking for the vertex. So +5, 1. And on this one, I'm going to get -6, 10. So that's a lot easier than using that -b over 2a and then taking that value and plugging it back in to find the vertex. So seeing it in vertex form, that's going to help us spot the vertex easy, and then we're going to use that to help graph. So let's go ahead and do that. Let's take a look at this problem. So the vertex is going to be -2, 4. And then the axis of symmetry, if you recall, the axis of symmetry is just x equals whatever your x coordinate is. So it's going to be x equals -2. And then it asks about the which way it opens. So this is where the a value comes in. Because my a value is -2, that tells me my parabola is going to open downward. And if it opens downward, then the vertex is going to be at the point at the very top. And so that's going to be a maximum. And it asks for the value of the maximum. Well, that's just going to be the y coordinate of the vertex. So the y coordinate is 4. So that means the maximum value is going to be 4. And then the y-intercept, well, 2 ways I can do this. I can either plug in 0 into the equation. So if I did 0 plus 2, I'm going to work inside the parentheses first. So 0 plus 2 is 2. I square it and I get 4. And then I multiply by -2. Now I'm at -8. And then I add the 4. And so that's going to put me at -4. The other way of figuring out the y-intercept is just go ahead and graph it first and then tell where it hits the y-axis. If you think that's easier, do it that way. So now let's go ahead and take this information and let's go ahead and make our graph. So much like what we did before, that vertex is going to go right in the middle of our little chart here. So since my x value is -2, I'm going to pick 2 numbers less than -2 and 2 numbers bigger than -2. So I'll do -4, -3, -2, -1, and 0. And now I have to go through the tedious task of plugging numbers in. So if I plug in -4, well, if you recall, they're symmetrical. Okay, your first value is going to match your last value, and then the next values, and then you'll have your vertex. So rather than plug in -4, I'm going to plug in 0 because we've already done that. We've already plugged in 0 when we found the y-intercept. So that means and then, see, I can either plug in -3 or -1. I'm going to plug in -1. So I'm going to work this out mentally. -1 plus 2 is 1. Squared, it's 1 times -2. Still at -2, and then I add 4. So I get 2. And I already know what the vertex is. It's -2, 4. So I've plotted all my points, or I've got all my coordinates now. Now I need to plot those points. So -4, -4. -3, +2. And sure enough, those points look like it's an upside down U shape. So let me go ahead and connect those points. Let's pretend that's not ugly. But that's what my parabola is going to look like. Now, a question that may be asked on your homework is compare this to the parent graph of x squared. So when I ask you to compare it, just talk about what's different than normal x squared. If you recall, normal x squared, let's do it in green, looks something like this. So what I would look for in the how does this compare to x squared, I would say it's upside down. The 2 as the a value tells me it's more narrow than x squared. So it's upside down, it's narrower, it's to the left 2 spots, and it's up 4 spots. So just tell me how it shifts. Tell me if it's right side up, upside down. Tell me if it's narrower, wider. That's all I'm asking when it says compare to the parent graph of x squared. Okay, let's do another example. So on this one, I can tell my vertex is going to be a +3, +2. Which means my axis of symmetry is going to be x equals +3. And then I don't see an a value up there, so the a value is understood to be a +1. So because it's positive, I know it opens up. And because it opens up, the vertex is at the very bottom, so it has a minimum value. And the value of the minimum is just going to be whatever the y-coordinate is. So 2. And then the y-intercept, we can wait till we graph it and then figure out what it is, or we can plug in 0. If we plug in 0, 0 minus 3 is -3 squared, I get 9. 9 plus 2, I would get 11. Or more specifically, 0, 11. but I'd be fine if you just put 11. So because our vertex, the x-coordinate is 3, I'm going to pick two numbers above it, two numbers below it. So I'm going to start with 1, 2, 3, 4, 5. And then I'm going to go ahead and take each of those numbers. So 1, if I plug it in, let's see, it's my -2, 4, and it's going to give me 6. And for the sake of time, I'm just doing this mentally. If I plug in 2, I get 3. If I plug in 3, I've already done this, and I get 2. And then it's symmetrical, so the next one's going to be 3, next one's going to be 6. So then I just plot those points. So 1, 6, 2, 3, 3, 2, and sure enough, it looks like those points make a parabola. So let's go ahead and connect those. Yeah, it looks a little bit better than the last one. Not much, though. So if it asks, how does this compare to x squared? Well, the a value is 1, just the same as x squared. So it's still upright. It's got the same width. I would just say it's to the right 3 and up 2. Let's do one more. And this one's not going to be pretty, but that's all right. Vertex should be easy to find. So the vertex is going to be a positive 5, negative 2. Which makes the axis of symmetry x equals positive 5. And then that a value, the negative 1/5. Because it's negative, we know it's going to be upside down. And then it's 1/5, that's close to 0, so it's going to be pretty wide. Okay, so because it's negative, it opens upside down. And because it opens upside down, the vertex is at the very top, so that's a maximum. And then the value of that maximum is going to be a positive 2. And if I plug in 0 for my y-intercept, I get 25, and then I get negative 5, and so that's going to give me negative 7. Again, for the sake of time, I'm just doing that mentally in my head. Mentally in my head? Of course it's mentally if it's in my head. Anyway. So let's go ahead and make our list. Since my vertex, my x value is 5, I'm going to pick two numbers below 5 and two numbers above 5. So I'm going to do 3, 4, 5, 6, 7. And then I'm going to plug each of those in. So again, I'm going to do this pretty quickly. All right, so when I plug in 3, negative 2, that gives me 4. Negative 4/5 minus 2, that gives me negative 2.8. If I plug in 4, that gives me negative 1. I square to get 1, so I get negative 1/5. So that gives me negative 2 and 1/5, so that's negative 2.2. 5 I know is going to be a positive 2. Or is that positive 2? Oh, I made a mistake. For my vertex, it should be a negative 2. That changes my maximum and minimum value as well. See, it's okay to make mistakes, but just try to catch them. All right, and because this is going to be symmetrical, I know my other values are negative 2.2 and negative 2.8. All right, so let's plot those points. And I get 3, and then almost negative 3. And then 4, and almost negative 2, just a little bit past negative 2. 5 is going to be right at negative 2. And then 6 is a little bit below that. And 7 is almost at negative 3. And if I wanted to, I could plot the y-intercept, which I know is going to be negative 7. And then because it's symmetrical, I know this point over here would also be negative 7. So when I go to connect those points, I can see the parabola being formed already. Told you this wasn't going to be pretty. There we go. There's the parabola. So the a value, that negative 1/5, tells me it's upside down. It's wider than normal x squared. It's to the right 5 and down 2. All right. I think we're going to go ahead and stop there. But if you guys have any questions, please feel free to let me know. All right. Have a good one.